Hey everyone, welcome back. We're still all stuck at home, so I wanted to continue on this little video series. Hopefully these are helping you guys get through this. I'm so proud. Every time I talk to you guys, I'm so proud of you for how hard you're working and how well you're holding up through all of this. I just want you to know, I cannot believe how proud I am of all of you. So launching in, I wanted to do a little bit more of solving systems of inequality so that we'd have a chance to practice with that a little. You guys actually did really well at this when we had to do it the other day in class where you were trying to find the sort of treasure hidden under my rug. But let's keep practicing with them in the meantime, just in case. So shrink my face. Bye-bye. All right, so let's look at this first one. So systems of inequalities. We're going to rearrange step one, rearrange each inequality so y is by itself. You can see that that isn't actually done for either one of these. That's okay. We're going to do it really quickly. Watch this. So for this one, I'm going to add 3x to both sides, and I get this. Y is greater than 3x plus 2. So this is the same thing, right? I've added 3x to both sides. I should remember to put in spaces. Looks funny otherwise, but this is the new equation. So I'm actually going to just delete the old one so it's a little less confusing. How about this one? Well, we almost have y by itself. We're going to have to divide both sides by 3 to get it. So I have y, and I'm going to steal that symbol because it's not a handy one, is less than negative 2/3 x minus 2. So this has changed a little bit, but in the end, it's not really any different, and we're going to delete the original. Now that we have that, we're going to graph each inequality on the same coordinate plane. If you're comfortable graphing from the other forms, you actually don't need to do that, but some people aren't, and I want to give that option. So now I'm going to try and see if I can graph lines. So for this one, I'm going to start at 2, and so I'm starting at the intercept 2, and I'm going to graph the line. Now this actually needs to be a dashed line. So when I say insert shapes, I think I have the option in a minute. So from here, here's my 2. I'm going to count up 1, 2, 3 over 1, up 1, 2, 3 over 1. So I should be at 8, 2. So there's my first line. Hey guys, sorry about that. I got called away by a goat. Gotta love doing this from home. Okay, so here's where we were. So we had this line and we started at our intercept of 2, y equals mx plus b. The b is the intercept for this axis. So I started at 2. I went up 3 over 1, up 3 over 1. Now this line should be dashed, so I'm just going to make it a dashed line because it turns out finally I can do this after the way I've always wanted to. No erasers required if I can manage to hit all of the right buttons in the right order. Let's move me. Maybe that's it. There we go. Dashes. We will dash the line. Perfect. Okay, so ideally that line would continue on forever in either direction, but for now I'm just going to leave it. So let's look at this second line. Now this line will actually be a solid, so I can go back to just a regular line for this one because we have y is less than or equals to. And I think this has a bit of a hard time when I get two things overlapping. Let's see. There we go. Nope. Oh, technology. You know what? Watch this. Nope. Let's see if I can do this one more time. Hang on. Apparently, I just had to pause it. Okay, so here I'm going to start at the negative 2. So this would be 0, negative 1, negative 2. And I'm going to count my slope back 2, up 1, 2, 3, back 2, up 1, 2, 3. And that gives me that line. Now I have to figure out the shading for both of these, and ideally I have to continue both lines on in either direction. So let's see if I can do that. Yeah. If I just hold the shift key, it will let me continue my lines, which is really nice. And here I'll do the same thing. So now we have to decide which side for each of these lines we would shade. So you know that I tend to be lazier than you guys, and I usually try and use 0, 0. So for this, this is the dash line, so I'm going to try and put in 0, 0. So every place I see y, I will type in 0, and every place I see x, I will type in 0. And what I have here is a statement. When I sort of simplify this, 3 times 0 is just 0, so I can, oops, delete those back out. 0 is greater than 2. Since that is definitely not a true statement, we need to shade on this side of the line because 0, 0 would have been here. Since it's not part of the solution set, we're going to shade this side of the line. Now, this program does not have a great way of doing that, so you're kind of going to have to bear with me. I'm going to pause it and add the shading, but it takes a minute. Okay, close enough. So I have the fill here where we would shade this side. Now for this other line, I'm going to do the same thing. Every time I see 0, every time I see an x or a y, I'm going to type 0. So I get 0 is less than or equal to negative 2/3 times 0 minus 2. And that's going to get a little crowded. But if I look at this, this is going to all collapse. Negative 2/3 times 0 is just 0. So I'm left with 0 is less than or equal to negative 2. That is also, of course, a false statement. So once again, I'm going to have to put in this shape. So I'm going to shade this, this side of this line because 0, 0 would not be a part of the solution. So I'm going to shade the other side. So hang on again while I insert that other. Ta-da! We've now actually graphed both of these and we can start to see where the graphs overlap. We see a shape in here where both of them are overlapped. And the question is 5, 1 a solution? So I'm going to look at 5, 1 and say no. In this case, that's not one of the solutions.